Coffee stains and name of chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. LeetCode, beast mode, 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 LeetCode, beast mode. This is not a main thing, really I'm a coder. Coffee stains and name of chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. LeetCode, beast mode, 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 LeetCode, beast mode.
Yo, Paul. Hell yeah, I'm getting the audio. We're mixing it. We're cutting up a video, shooting a music video, everything for that. All right, let's get it. Who do we got today? Yo, Paul, how'd your interviews go, by the way? You're done them, right? How you think they went? Holy, that'd be crazy. Is it an MPK? Dude, that'd actually be nuts. That'd be crazy. Well, fix something. Why would it be awful? Hold on, let me get my camera. No, I think they do a bit more than that. Sai, what's up? Jalen's there? No, I don't know. I work with a bunch of data engines and they actually do stuff. Yo, what's good?
Yo, what's up?
How you doing?
I'm doing good.
Nice, cool. Let's see. Thanks for taking the time out for this interview.
Yep.
Oh, I think it's feedbacking. You have my stream open?
No.
Okay.
Let me open it real quick.
Oh no, cause don't play because it messes with the sound a little bit.
Okay.
Cool. All right. What do we have here? You've solved 60 LeetCode questions. Northeastern University. Nice. So have you done any internships?
No. I'm rising a sophomore, so I'm about to look for some.
What is sophomore? Is that third year or second year?
Second year.
Oh, you only finished your freshman year?
Yeah. I just finished my freshman year.
I see. Okay. So, how are you with LeetCode?
I'm not gonna. I think I'm still pretty bad at it, but I'm trying to improve right now for the upcoming like internship season.
Yeah.
Because right now I'm getting like OAs, but like some of the OAs are pretty hard.
Yeah, no. Like, oh, for some reason I hear my voice whenever I talk. It's like feedbacking. Maybe it's the mic. Do you have like headphones?
Yeah. Wait. Hold on. Let me put them on real quick.
This is trippy. You good? John, what's up? Yo, John, what are you up to today?
Alright, is that better?
Okay, so let me see. Test. Yeah. Do you have a mic or something? Like a proper mic?
Nah,
Yeah.
nah, I'm just
Oh,
using
okay.
my computer mic.
I was wondering. I was like, how's it doing that? But yeah, it sounds good now.
Okay.
All right. Okay, let me start this up. Let me start the video. Wait 1 sec. Let me check my. All right. Hey everyone. So today we have somebody from Northeastern University. Rising sophomore, solved around 60 LeetCode questions. So, which LeetCode questions have you solved so far? Were they mostly just in the blind 75 list, LeetCode 150, or
Oh,
whatever?
honestly, most of them were like random, and like some of them I done like a little bit during high school, but like I haven't had like much time to practice like during this semester. So
Oh,
I
nice.
just like started like practicing again in the summer.
Nice. So you did some
So
during high
yeah,
school?
yeah, only only like a few, but like I don't really remember like the solution to like the
Yeah,
problem because it's been so long.
that's crazy. When did you start coding?
Oh, I didn't like actually officially start coding like I guess until like my first year of college because my high school, we didn't really have any like comp sci classes, right?
I
It
see.
was like in like a pretty rural area.
Yeah. So what can I ask you? Is anything fair game? Should I ask you easies, mediums?
I guess anything is fair game except graphs because I've not done any graphs.
You've not done any graphs? Okay, let me
Yeah.
go. Let me look for a question. All right, I got a good question. Let's see. So we're gonna test some of your string processing abilities.
Okay.
Let's see how you perform. So this is the first question. So I just want you to write a function that takes a string containing only lowercase letters and returns the length of the longest substring that contains the same character. So here the longest substring is B's, and that's a length of 3. This one all characters are different, so it's just 1. And here all characters are the same, which is 5. So write me a function with this function signature that is able to do that.
So I guess I'll start with trying to understand the problem. So I guess we're trying to find a substring, the longest substring, given a string, right?
Yep.
And can the string be empty, or is it always at least 1?
Yep. It can be empty.
Okay. So in the empty case, would it just return nothing? Would it return none?
0.
Or
Return
like
0.
string? Okay. Okay. Then I guess looking at this, then I guess I could write some test cases, I guess, too. I just say given.
What keyboard you have? Sounds good.
Oh, MQ80. So if we're looking at this test case, we could see like there's two substrings here, right? That are continue. Like, yeah, that would continue. I actually put an extra. And then we choose the longest out of this.
Exactly.
Let's say this is length 2 and this is length 3. So then our return type here would be 3, right? Or is it? Oh, I guess it would be B, I guess, right? Okay, so looking at this problem, since we're counting like I guess we're kind of we're trying to find the substring. So I guess we could first maybe convert the string into a list for easier manipulation.
Well, we just need to return the length of the longest substring, not the actual substring.
Oh yeah, the length, yeah, 3. So okay, so if all characters are different, we could return 1. Okay, so I'm thinking we could maybe do a linear scan
Sure.
of the string. So let's say we start here, right? We start here, and we're gonna check if the next element or the next string is the same as this current one. If it is, then we could say, then we can update the frequency of that string. If it's not, then we go back to 0 and we make this our new substring.
Okay.
Okay, so I think, is there anything else I need to cover? I guess, yeah, another edge case. All different would be 1, right? So I guess we could start at the beginning. Actually, I think we could. Actually, that doesn't work either. I guess we could start at the beginning. So let's see. See, I'm trying to think of like a way to, I guess, store the substrings, like the length of the substrings. I guess we can maybe make use of a hash map to store each subsequence and the substring is, I mean the length of the substring associated with it. Then I guess find the max. That works.
Well, we just need to return the longest sequence.
Yeah, we're trying to return like the number, right?
Yeah. So we don't really care about any other sequence.
Oh yeah, okay, yeah. Okay, so yeah, so I'm trying to think how I could like store the substring because you could find like the first sequence, right? Then you know the count of the first sequence, but then let's say you find the second sequence, you also need to know the count of that. That's why I thought maybe you could use like a hash map to like just store the sequences itself.
I mean, you could, if you want to. What would be the trade-off?
Using like the hash map, I guess more memory.
Yeah.
Like I guess it'll be O of n for memory.
Mm-hmm.
But I know there's definitely an approach well hashmap. Okay, I guess
mean-
actually before writing this code, I'm gonna just like write out like a better plan for this. Okay, so yeah, I think I guess can create like a stack, and inside the stack, I'm gonna store like a tuple, I guess. And I guess the first tuple value will be the substring, and the first tuple value, actually I just could create a stack and just store the.
Create a stack.
Oh
Here,
wait, what am I?
just do the hash map, and then we'll
Okay,
work
just
from
do the
there.
hash map?
Just do the hash map.
Okay. I guess we could have like a running count. So we first check. Oh wait, start here. Actually, yeah, I think we start at the first index. Then I guess you could look backwards and see if it's the same. If it's the same, you could update the running count because that's another frequency. And so if the current string is the same as the previous one, you could say the running count plus 1. Else, if it's different, we could update the current string at this time. And now we have to figure out like a way to oh wait, okay, yeah, okay. So we have to have like a max counter, right? Our current like max. Then let's say else if the running count is greater than our current max. We could say the current max is now our running count. And here, the other case that we need to make sure is that if it's different, right, we want to reset the running count back to 1. I mean, back to 0. And we also want to update our current string to be the string we're on. So Okay, so I think I need to do like a quick like dry run of this.
Yep.
So just put it here. So we have current max, running count. String. So let's just use this first test case, I guess. So we start at okay, yeah. So this is the for loop, right? So we start at index 1, right? So start at index 1, which would be like A, and then we set this.
One tip is you can just do something like this to show where the index
Oh,
is.
okay, okay.
To just make
That
it
makes-
easier.
Yeah. Okay, yeah. So we start there, then we look back. We look back and say, oh, A is the same as this one, right? So we update the running count to 1. Well, I guess we always want to start the count at 1 because it indicates it's the current one we're on, so the count will always be 1 for that one. So we start at 1 here, then we look back, okay, it's 2. Then wait, hold up. Then it's 2 here, then we look to the next one. Oh yeah, we also have to update the current max to 2 now. Now look back to the next one. Since it's different from A. Oh wait. Yeah, since it's different from A, we set the our current string to be B, and we also have to reset the running count again to 1. Then yeah, we keep looking to the next one. So if this becomes 1 and we move to the next one, it's 2. Right. Then we look there. Then and we look behind. 2. Then the last one's here. Yes. Oh, I guess I forget to add the very last index, I think. There. So it should be there. Oh wait, what's this? I think. Is there anything I'm missing here?
But then we just had AA. What would yours return?
Oh, I guess you would just return 2.
Based on your algorithm?
Oh, based on, let me see. We start here. I think. Yeah, so we get index 1, current, back, running count 1. Oh, I guess we'll just end. Right?
End? Yeah, we end with what? What would be the max there?
It would just be 1.
What is the answer? Yeah.
It's supposed to be 2.
Okay.
It's because it never gets I guess updated. Oh, I get it. Wait. Oh, I guess no. You want to like, you want to basically check at the end. Yeah, because the
that's
last
not gonna
thing.
work. Or that doesn't change anything, really. Because even your last, like the last iteration will always hit this, so this is kind of the same. Like your last iteration will go, it'll update the current count, and then it'll update the max. So it's not because of this. It's a different reason. Try dry running it.
Okay. So. Look back here. Oh, I guess. Yeah, I didn't add the. Because when you set the new one,
you have
you
the
want
running
to.
count there.
Do I?
Oh. Yeah. You already handled that case. If it's not the same, you set it to 1. Try dry running it.
Yeah. Okay. So you start at, you guys index 1 here, right? Then the current string is A. Then I guess our current running count would also be 1 here, right? Then
Well, it starts at 0, right? Starts at 0.
Yeah, it starts at 0. Got ahead of myself, but yeah. Okay, then let's say during the first iteration we get the current string, and then we hit the first if statement. Since they're just saying, yeah, this code is actually like really not well maintained.
No, it's good. It's good. It's fine.
Okay.
You don't need
I was
that.
just gonna fix it. I was just gonna refactor it, but okay. So yeah, our running count. We're at index 1, so here, then our running count here becomes 1. Here, then running, since the running count is greater than our max. Since greater than our max is 1, but then the code just ends and doesn't add like the itself, I guess.
Well, it did add itself.
Well, it doesn't add like the previous one, right? So can I? Yeah, is that instead of comparing it? Actually, would that work?
Okay, I'll give a hint. It's the way you initialize the variables.
The way I initialized.
You could fix it if you initialize the variables in a different way.
Oh, like 1 here.
Yeah, because you're counting the first character as already a substring.
Yeah. Oh, okay, yeah. Because when we look back, we add 1. Yeah.
Okay. So yeah. Okay. I think it's good. Run it on a few test cases. Like just in the code.
Wait, like dry run?
In the code, just run it and just ensure it works.
let me print. Okay, yeah, okay, that works.
Nice.
Okay, yeah, I'm just kind of nervous right now.
No problem. And then
Yeah.
you can't do tree. Can you do trees at all?
A little bit. I'm better with like linked lists or like.
Okay. Let's see.
Like I'll say my tree skill is probably around the same with like grass right now.
Hmm. Let's see. Let me post in the next question. Have you solved this question?
I don't think so. But
Okay.
okay, so you're given price array.
So yeah, this is the second question. I'll quickly read it out. You're going to be given an array of prices where the price of I is the price of a stock at a given day. So the ith index is the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Tell me what's the maximum profit we could achieve based on the prices. So I'll post in some examples.
Okay. Okay, so let me just. Okay, so look at this. We're choosing a time to buy a stock, right? Like it could be any time frame.
Yeah.
Then I guess we're selling it at a future date.
Yeah.
And we want to maximize this profit. And I guess we're given an array of prices. And the array is never empty, right? Or can it be?
Well, it could be empty.
Okay. And if it's empty, what would you return? Like 0? Or like just nothing? Or
0.
just none? Okay, return 0.
The maximum profit is $0. You can't make anything.
Okay. So I guess I could write some examples first, I guess. Like work through some examples. I'll just take the first one.
Yeah. Makes sense?
Yeah. So I guess if we have 7, right? So if we start with 7, and then we keep looking, and I guess we try to find the maximum price, which is I guess 6. So I guess 6 minus 7 1, well -1. So we're losing money there. Then I guess we try the next value, and we look for the. Oh, I guess we look. Oh wait, I guess yeah. Look for the next, I guess maximum, which is 6. Oh, actually, it should be the other way around, I think, right? Because max profit would be 5 here because we bought it at 1. And we sell it, so this should be full up too. So we're actually losing money here. And then I guess if we're at 5, the amount we're buying it for, then, and we could only purchase it in future dates, right? We can't like go backwards.
Yep.
Okay, yeah. Purchase it at 5, it'll also be 6. And then I guess we purchase it at 3. Also, yeah, I guess these are all 6s. Just 4. Oh wait, I missed. Wait, can you sell it on the same day you bought it?
No. Well, if you sell it on the same day you buy it, you don't make anything.
Yeah, you don't make anything. So I guess, yeah, I guess I'll skip 2. I guess 4. Then.
Why are you comparing 6 with like 5?
Like this?
Oh, okay. Oh,
Because if we bought it when the price was 5, right, and we sell it when 6,
yeah,
the profit's 1,
yeah.
right?
Makes sense.
And then, oh, I mistyped here. This was supposed to be a 6. Right, we bought it at 6, and we can only sell it at 4 because, well, I guess that'll be a negative profit. But okay, so looking at this, I guess you could do like, I guess one solution would be like maybe brute forcing. You'll try like every single combination, and you will, like, for example, you start 7, then you try to find the max of the rest of the array, then you find the difference.
Sure.
But I think there's probably like a more optimal solution for this.
What would be your runtime there?
N squared, because you're going over it twice, basically. Well, you're going over n squared time, basically. I guess I could start planning. So yeah, that was like brute force, but let's see. Let me think if there's a faster solution to it. Okay, actually, I'm gonna just start writing the brute force and see if I could come up with a more optimal on the way.
So what's the bottleneck with the brute force?
Is it in the constraints?
Or when you think about the brute force solution, what makes it so slow?
Because I guess you have to like recompute, right?
Recompute what?
Like you have to check. Well, I guess what makes it so slow, because you're trying like every single combination. You're doing more than like a one-pass solution.
Yeah, but like for each element, what's the bottleneck?
You have to find like a future date, I guess. That
is the maximum, right?
Yeah, that is maximum. Yeah.
How can we speed that up?
I guess can we keep storing? Can we first try to see? Wait, yeah. Um, let's see. If we start at 7, then we go next.
Because the bottleneck is for 7, we need to know to my right who's the largest. Then for 1 to
Yeah.
my right, and it's taking O_ven to go find into your right.
Yeah.
So is there a way to speed that up? Maybe know right away. Oh, my right, the largest is this.
I guess can we keep? Can we like keep storing like something with like the minimum price? Like we want to find. I think we want to find like which one will have the minimum price. So we start at 1. Or actually, can we find? So let's say we're at 7, then if we just compute this side once and find the maximum, then oh wait, that wouldn't work either. You have like a hint?
Yeah, let's see. Okay, try to flip it in a different way. Try to flip it as in maybe for each element try to sell. So for each element try to sell, and if we're trying to sell, right, then we just need, what do we need to know to the left, not the right? Like, because right now you're trying to buy and then see where you can sell, but try to sell at each.
So like you go backwards and you're trying to find the minimum.
Or I'll give you the hint would just be try selling at all times.
Try selling at all times.
Like, instead of thinking about where to buy, think about it as where am I gonna sell? Or if I sell here, what would be the result? You can move from left to right.
Okay. Wait, so I'm supposed to be moving left to right?
Yeah. Well, because if you're looking to sell and then you're moving from right to left, then it's still the same problem where you need to look into the future.
Mm-hmm.
What you're trying to avoid here is having to look into the future or being able to look into the future fast. So, for example...
Oh, wait.
Try selling here. Try selling here. Try selling here.
Oh, wait. Can we just keep a counter then of the current min and current max? Then we just do a single pass through it.
How would that look?
So, okay, I guess I would start writing the code.
Well, you don't need to, let's iron out the approach first before you write any code.
Okay, so I guess we're gonna have like a counter thing, right? So let's say our max price 0 and our min price. So I guess we could first set our max price to be, I guess, the current index. Then I guess our minimum price, we're gonna compare if 7. Well, actually, this should be like an infinite number or something. So I think it's like this, right?
It should just be 7 here too, because the minimum price we seen was 7. Right?
Yeah. The minimum price would be 7, and the max price will also be. Wait, the minimum price would be 7.
Like what
Oh
does the
yeah,
minimum price?
I was trying to do like a negative. Actually, you can do like a negative float. Oh, okay. I guess yeah. You're right. It should be like the same, right? Then we can go to the next one. You're looking at 1, and you're checking if 1 is less than 7. If it's less than 7, you could just set this to 1, right? But if it's greater than 7, you could set it to. I guess you could set it to. Yeah. So then I guess you keep looking until you find another has a higher price than it.
Here, try. This is getting closer, but you're still going in the wrong direction a bit. Like try to sell at 7, sell at 1. Pretend I want to sell at 5. What do I need to know to my left if I want to sell at 5 to maximize?
The minimum price to the
Okay,
left.
if I try to sell at 3, what do I need to know to the left?
The minimum price to the left.
What about at 6?
The minimum price to the left.
Okay, and if I'm moving from left to right, will I know the minimum price?
Oh, okay. Okay. So you want to track the current minimum price, then just subtract it with the current number you're on, I guess. Would that work? So I guess. So you do it like a for loop through the whole thing, tracking the current minimum price, then also subtracting the current index you're on to the minimum price, and if that's greater than our like I guess max profit, then we could just set that to the new max profit and return the max profit at the end, right?
Yep.
We're giving an array, right?
Yeah, we're given an array. We're given something like this.
If the current so I guess this should be set to yeah. Right, we're checking if it's less than, then we could set the min price to be the current stock. And then we're gonna say max profit to the minimum price subtracted by I guess our current index. Whoops! I actually closed the thing.
Where? Oh, okay. No problem.
Let me rejoin real quick.
Yeah.
I actually hit like a keybind. Okay. Yeah, I guess that'll be our. Then I guess we could take the current max versus the at max. Then I think I'm still missing like some case here, I think.
You can try running it.
Alright, so let's just start with this. So we have 7. Let's see if we could like this. Yeah, so first index we start at 7. We check if it's less than the. Can I create? Yeah, we start at 7. Okay, so we say our minimum right now is 7. Then we go to the next one, and I guess we also our profit will still be 0 because 7 minus 0, 7 is 0. Then we go to the next one. Our memrise will be 1, right? Then we check the profit. We checked our minimum price. Oh, this should be flopped. Yeah.
Okay, try running it on all the test cases that I have up there. By just not dry run, just run the function, create a function. Are you running Vim? Chat's asking.
Yeah, I'm running them.
Yeah.
Is there any other test case? Was it just 2?
Yeah, that's good enough.
Oh, I missed a bracket here. Five and 0. Okay.
Cool. All right. Yeah, that's pretty much it. How do you think you did? How was that for you?
Oh yeah, I was like, I was too nervous, but like I was thinking of the idea, but I just like kind of like, I guess write it out in code. I guess.
It was just hard to implement.
Oh, actually, I wouldn't say it was hard to implement. I was just like, I kept getting lost in my own thoughts. I guess just cause nerves.
Yeah.
Yeah.
No, it's fine.
Yeah.
Cause okay.
Yeah, that's why I'm here like practicing, right?
Exactly. It's better to have the nerves right now than when you actually do the real interview. So let's go through the feedback on question 1. So I think you have a pretty good overall process of clarifying the question, discussing one or more working approaches, being able to write the code, dry run the code. You actually caught a bug during one of your dry runs. So I think you have a good process. You clarified the question. Yeah, you thoroughly think through the edge cases. You're writing them out. But then I think you're just having some trouble figuring out the maximum. So you talk about different approaches. Like, could we take the max? Like, could we create a hash map of all of the different substrings and then take the result? But then you eventually came to this approach. So I think, yeah, you eventually got there. But yeah, I just noticed in some of the questions you're having trouble finding the max or working with the max and minimum and like having a maximum there. I think you could leverage the max and min functions a lot more. For example, are you following my cursor?
Wait, how do I follow you? Okay,
just click on me in the bottom.
Oh yeah. I could set max here. Yeah.
Yeah, you could just use max here, and then even in this the second question, you can just calculate min here.
Oh yeah.
You're using
Yeah.
max here, but yeah, just leverage the min and max, and then just return it.
Yeah.
You eventually got there, but it took a bit to figure that out.
Yeah.
And then, yeah, you're having trouble with some of the edge cases. So with the running count, starting equal to 1 took a little bit to figure it out, but yeah. So that's the main part I would just worry about is just having cleaner code by just using the min and max, and just knowing how to capture the final result. Whenever you say minimum or maximum, this is a pretty common pattern of just storing sort of a current max like this, and then eventually returning that.
Oh, okay. Okay, so what I did in this.
It's a pretty this is a pretty common. Whenever it says maximize and it's not some dynamic program or anything, you're gonna have some sort of condition like that where you're maintaining a current global max, and then you're eventually returning that. So just make sure you understand how to do that without using a hash map or a stack or anything like that.
Yeah.
By just using one variable. Second question. Yeah, second question. You had a bit of trouble figuring out what would be the optimal solution. So I think for this one thing that you could also learn, you don't really need this for this question, but you should learn prefix sum pattern. So it's basically when I asked you the question at first, when you're saying when I was like 7, right? How do you look ahead to find the maximum? Or 1, how do I look to my right to find the maximum? You could pre-compute. So understand that we could pre-compute. How would I pre-compute? Well, I can create a new array called to the left maybe. And then basically I could start from, or I can create a new array called largest. And then I can move from right to left, storing the largest that I've seen. So 4, what's the largest I've seen? Here, 6. This is one way to pre-compute. You don't have to do this for this question, but understanding that this pattern exists. So you can see 3, the largest I've seen to my right is 6. I could just maintain a count, or a max. 6. 6. You see what I'm doing there? Line 55?
Wait, can you go over that again?
So I can pre-compute the largest. I can pre-compute the largest to my right. So for example, I move from right to left. 4 is the largest, larger than anything to its right. Then we go to 6. 6 is the largest number we've seen.
Oh, okay.
Right here. 6 is the largest number we've seen anywhere to the even anywhere to the right.
Oh, so this ensures like every time we look to the right that we'll always get like the max.
No, this is like a separate data structure that we store. So every time we look at prices, right, and we ask ourselves, what is the largest element to my right? We can reference this largest array to see. It's like because we already pre-computed it, so we can cut down the time from O of n to O of 1. That's what I was asking. What is the bottleneck? How can we speed up that operation of looking to the right and finding the largest element? Like the way that we can optimize that is pre-computing.
Like you'll create like a separate data structure, right?
Yeah.
Just the stack. Okay, but isn't this just more time or no?
Well, it's like this is just one solution. The solution you eventually got to was the optimal, but I'm just showing you other approaches that you could do. You need to understand how to solve questions in multiple different ways. And this is just O of n. The only issue is it just takes up more space. It takes O of n to pre-compute the largest, and then O of n to eventually calculate the best price. Do you get this solution? This alternative?
Yeah. I get this solution. So you're basically just saying that if we're going to the prices since we already have like a pre-computed table of the maximum, we could just always look to the right of the largest of our current index, and that will be our max. And you just use that.
Yeah, exactly.
To
so
max profit. Yeah.
We look at 7. Who's my largest to my right? I look here. Oh, the largest
6,
to my right is 6. And then pretend we're at 6, right? I asked the question, who's my largest to my right? It's 4. So at any moment in O of 1 time, I could see who is the largest to my right. So that's just, you don't need to do it for this question, but in general, when I ask you, okay, how could we make something faster? You could think of pre-computing.
Yeah.
Yo, mods in the building. Yeah. Otherwise, yeah. I think for a sophomore, you're pretty good. But just continue to practice.
Yeah.
I don't think you have trouble coding at all. It's just getting to the right solution.
Yeah.
All right. Cool. All right. Good luck.
All right. Thank you.
All right. Catching on. See ya.
See ya.
There you go. He's pretty good for a sophomore, not gonna lie. Yo, we got somebody joining in from Tunisia. Yeah, before I had a lot of trouble making sure I capture all the edge cases. We're only on the we're only hopping. It's only the second candidate now. We just had the first one who's a sophomore student. Second student is someone from Tunisia. Let me take a 2-minute break. The next person is coming on right away though. Go to my channel link. Go into my channel and you can book through my channel. All right. Got the next candidate. So LeetCode of the day. Oh my god. That's torture. No, it doesn't seem that bad. I still don't want to do it. Let me message this guy. Yeah, I mean, it's not simple. It's not simple to master arrays because there's so many different variations of arrays. Arrays is probably the hardest one to master because there's just so many different array questions you can create. So I would just make sure I learn the basic array patterns and understand basic array operations, and just probably spend more time doing array questions than graph and tree questions because there's just more diversity there. What do I think is the easiest pattern? Probably a depth first search or recursively. Which patterns would you for sure know? Brain melt on DFS trees? No way. Cyclops, that's a lie, man. I've seen you solve some hard questions. Rafi, what's up? If you learn these patterns that I mentioned here, honestly, you should be pretty good. So learning the 2-pointers, the different ways to do 2-pointers, the sliding windows. These are the top 6 ones. But then there's going to be a ton of... Dude, there's a ton of different array ones. But I think just master these 6, make sure you understand them fully, and then just start doing the small twist. Stacks are asked a lot. Have you done today's... What's POTD? Problem of the day? No, I don't really do the problem of the day. Why was it a hard question? I was looking... How do you solve this question? Simple for loop. Pick your biggest boost at fall. Slide and update now instead of moving to the next window and recalculating every time. What the heck? This is one of the contest questions. I was working on it the other day. I had no idea how to solve it. How nervous was I in meta rounds? Not that nervous because I did a ton of interviews in the past. But honestly, the first time I ever interviewed for a company where the salary was insane, I was way nervous because so much money was on the line. But then after I'd already did a ton of those interviews, I wasn't worried no more. But pretend you're interviewing for a 100K job versus a 300K job, you're gonna be way nervous on the other job. Even though it's just... That's why I don't even look at levels FYI when I'm applying for a job these days. Do I have to ASA ASA OA? I didn't get an OA for meta. Where's this guy? Guy flaked. That's crazy work. Give me a sec. Best time to buy and sell stock using a strategy. You're given two integer array prices and strategy, where prices I is the price of a given stock on the ith day. Strategy I represents a trading action on the ith day. Dude, actually, I'm gonna do a different challenge. Okay, since this guy flopped, I'm gonna try to do as many blind 75 questions as I possibly can in an hour. See which one? Oh, you want to see this one? Okay. You're given it two integers, prices and strategy, where prices I is the price of a given stock on the ith day. Strategy I represents a trading action on the ith day, wherever -1 indicates buying one stock unit. 0 indicates holding the stock unit. Indicates selling one unit of stock. You're also given an integer k and may perform at most one modification to strategy. A modification consists of selecting exactly k elements and setting the first half to hold and then the last half to sell. The profit is defined as sum of the strategy times the prices across all days. Return the maximum profit possible you can achieve. Where's K? Do they give us K? Oh, they give us K. There are no constraints on budget or stock ownership. All buy and sell operations are feasible regardless of past actions. Okay, that makes this question way easier. Because if we know there are no constraints on the budget or stock ownership, we can just pretty much we just need to do a sliding window. It's pretty easy. I didn't realize that there's no constraint on the budget. So let's look at here. There's only two windows. Well, if the strategy is -1, 0. Do we need to choose a K? At most once. Okay, so we can choose to. We have three options. Do nothing. Do nothing. So we're left with -1, 0. We're left with original. We can change from in 0. We can do option 1 here. We can do option 2 here. So basically what we need to do with option... Wait, we'll see what the answer is. We just need to basically hold. We can hold here. So we can convert hold here. And then we could actually just sell here. So what does that mean? So pretend we go, do we start off at $0? Okay. Oh no, this is just a stock price. So 1 is selling. So if we sell at 2 and 10, we get 10. And then we hold here. Then we could sell here. Or we could buy here. That's -4. And we could sell. So we can buy here, that's -4. We can hold, and then we could sell. And so this will equal 4. And then this one will just equal, this one will equal 4 again. So yeah. So all we really need to do I mean, the brute force is just calculate all of them. So brute force is, so the brute force is for each index. So brute force is first calculate max of current strategy. Then for each index, like apply these changes, apply modification, apply the modification and see the result, maintain a max, and then return the max. That's brute force. But then for each index, we need to, this might take O of n. So this is O of n. This is O of n. Because we applied the modification. And then this is just O of 1. So this leads to O of, brute force is pretty much an O of n squared solution. Yeah, this might just be a simple sliding window solution actually, yeah. Because all you need to do is pretend we maintain the maximum here. Well, the maximum is equal to 4. So we say max equal to 4. Is this not hard though? So you keep the sliding window, you have a left and right pointer. Sliding window, and you keep a fixed size. But essentially what we just need to know is with this sliding window, we'll put this to 0, and then we'll keep this, we'll sell here. So if we keep this at 0 and sell here, keep this at 0, that means hold, and sell here, we would actually get 2. Or we need to know what the current value of the sliding window is, so we can subtract it from the result, because we're going to be making a change. Maintain current value of window, so we can minus from the result. So here, we'll say current window is actually equal to, if we buy, that's -4, and then we hold, the current window is actually -4. And then we could keep a replace window. So the replace window would actually be 0. Would actually be we don't touch this one because we're holding, but then we sell 2. So the replace window would be 2. So we know that the current max, if we follow the whole strategy, is just 10. If we do 4, well, the current strategy is 10. If we just sell here by 0. Wait, if you sell here, or you buy, so you're -4. You sell, or you hold. You sell. Wait, that would just be 4. Wait, let me look at. We need to start with the max. So the max is if we start at 4 to 8. So if we just take the strategy without making any changes, that would be, we start at 0. We buy a unit at 4, so we get to -4. We hold, and then we sell, so we get to +4. Right, that's the max right there. So if the current window is -4, if we zero this out, then we get to 0. And then if we sell, we hold, and we sell. Wait, what happens if we hold? If we hold here, oh, this is tricky. Oh no, we can't maintain the max. Okay, wait, maintain. Okay, we have to do some sort of sliding window, I think. Or we just need to know how many minimums. We just need to know how many buys I'm converting to sell. Is that all we need to know? Because I'm converting from this buy to sell. So if I'm converting this buy to a sell, yeah, we just need to know how many buys we're converting to a sell, or how many buys are in our last half, and then how many. So if we have 4, yo Alpha, what's up? I think we just need to be able to figure out how to apply the modification fast. So if I'm converting so if I know, yeah, well, you could maybe do a prefix sum, because we already know everything that happened for this strategy, and then everything that happened in the other strategy. Yeah, we could probably have a prefix sum, because pretend we have like x, 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 right? And then we have x, 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 or y, 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 y. If we just care about this window, we already know what the result is if we keep like buying and selling from here, and then buying and selling from here. We just need to modify this area. So how do we modify this area? Like, one way is just to loop through it, and like for every -1, if we were to buy it, delete it. But yeah, what we could do is, yeah, we can know the prefix sum here, and the prefix, yeah, I don't know if we even need a prefix sum. We just need a sliding window. . because we might. Okay, I'm gonna do it with. Okay, I'll just do it with a prefix sum. So we have a XXX. Okay, now let me think about this real quick. How are we gonna convert all of the elements from 0 to 2? Well, we just need to be able to subtract the back half. Yeah, I guess we could just do a bunch of prefix sum. Because we just know that we just need to know the difference between this and this. And then remove that difference from there. Because if we know the difference, pretend this is 0 and then this is -4. Yeah, we just need to know the difference because since we're not actually buying any, since we're actually not selling anything there, the stock price won't actually move anymore from this point. So it actually won't move anymore from this point. And then you could also, like, because we need to be able to clear out the whole window. So to clear out the whole window, oh yeah, you could just take the, to clear out the whole window, you could just, yeah, look all the way back here and say this is the price. Then you could say, what happens if I sell everything? So you just need to be able to ask the question, maybe you could do a prefix sum of just like if you keep selling on every single day. So if you know what happens when you sell on every single day, you could easily calculate what's gonna change if I sell every day for a given range. So I can see how much I can sell if I give for this different range. What happens if, so we can just have pre-compute a bunch of different stuff. Pre-compute if we follow strategy. So if we follow strategy from here to here, what do we get? Then we could follow, what happens if we follow the strategy from here to here? But we can, in order to get this, I think pre-compute if we just follow the strategy the whole way through. And in order to get the x's here, we could just minus what happened, or yeah, here it will just tell us what happens if we follow strategy. But to find this range, we just need to subtract off this area, and we just know what happens if we pre-compute. Something like that. Bro, that's, wait. But I think it might trip it out because it might trip it out because this result right here, well, like then we would have minused out what happened here because we start at 0. Yeah. Pre-compute if we follow the strategy. Pre-compute if we sell every single day. And then just kind of maintain that. Does that make sense, chat? So if we follow the complete strategy and then pre-compute if we sell every single day, we need to pre-compute if we sell every day so we can set the last K divided by 2. And then we could just like do a couple calculations to just figure out, like while we're sliding the window, like the X here, the Y here, and then what happens to this subarray. Chad, does that make sense? I think that would work. Oh, this would be like 1. This would be side. So all we'd have to do is, yeah, zero this out. How would we zero this out? Yeah, to zero this out, we pretty much just take what happened here. Because if it's 0, if we're just holding, that means we just don't do anything. So we just take what happens here. So we add x here. Alpha, does this make sense what I'm trying to do? So we pretty much just have to calculate this range of what happens if I sell within this range here. Then I just need to figure out what would be the values if I followed the basic strategy here and then basic strategy there. So just kind of those 3 operations. I think that would work. Let me try it. Let me try it and see. Let's see if I get anything wrong. So it's like a weird ass solution though compared to what other people probably would do. Dude, I suck at these contest questions. Okay. So basically we're gonna have our strategy. So we're gonna have so if we follow strategy or sell every day. So if we sell every day, you did it in O1? So what's a current strat? Okay, current strat is we start at 0 and then we say for price in range prices. Yeah, I could probably do something there for I in range strategy. For I in the length of strategy, what we're going to do is if, or let's just a new, for index strat in range strategy, if strat equals 0, you just continue. Elif strat equals -1. You buy the stock, that means minus equal strategy at the index. Else you're selling else. Oh no, it's the prices. So if the strategy is 0, you continue. If it's -1, that means you buy. So you have to negative, and then here you have to add. And then pretty much for sell every day, what we need to just do is then for this you just append the current strat. And then for sell strategy, sell every day, you just append prices at the index if index equals 0, else prices at the index plus sell every day at index -1. If the index equals 0, Let's do this. Else prices at index plus sell every day. Oh, no. Oh, because we're not even adding at sell every day. Wait, sell every... Why would that be out of bounds? Because for the 0th index, it's there. But then... Let's just make this simple. If the index equals 0, we just append the current price. Else, sell every day. We add the current price at the index plus. Oh, okay, we just have to do sell every day. I see. Something like that. K-pop demon hunters after seeing. No way. Wait, why is the... Elif strat equals 1. Okay. So if we follow the strat, let's just assume that works. So now let's store a result. What are we trying to return? The maximum? Result. Holy. So I gotta do more contests. So what are we gonna do for I in range length of prices? What we're gonna do is I kind of have 4 and 6 here. So for pretty much what's gonna happen is, what is this? This is, where did I print? I think this is the strategy strat. This is like if we follow, and this is if we just sell every day. So if we follow every day, if we followed up until this day, so we'd get 14 if we. So if we only followed after this point, we'd get 4. But then here, okay, but then we look back, that's 0. Okay, and then we sold. Okay. Here we'd have 6 minus 4. Okay. I just need to figure out the pointers. I think this would work. All we'll need to do is pretend we have like the strategy here. Pretend we wanted to flip this one to 0 and the other ones to 1. If we wanted to flip this to 0, this would... So here, we'd have to calculate the left and the right. And then R plus 1. I'm interviewing myself. I'm doing one of those competitions. Right half. Yeah, I'm taking L. Left half. So if I calculate my right half, essentially if I'm at I, right half is equal to, so is K equals 2, so right half is equal to 2. Right, yeah, right half is equal to right half is equal to, okay, where's S? Okay, if we follow this strategy, there's going to be some out of bounds. So maybe we just have to do for minus k. We'll worry about the out of bounds after. But essentially, this is what we're trying to capture. So how do we capture it? This is, we'll call this the right half. We'll call this the left half. So the right half is pretty much, you take the current index you're on, and then you add k. So, okay. And then you pretty much follow the strategy from the right half all the way to here. Okay, so how you would do that is you would take, bro, this question is annoying. -1. So that's how much I would get if I followed this strategy. Yeah, I don't know if I'm gonna be able to solve this. If I follow the strategy from 4, but then if I minus -4, then I get 0. Why does that make sense? If I follow the strategy, that means I only sell at 8. That means I would have got 8. Hold up, I'm close. I don't even know if I confused myself now. If I just straight bought this one. Oh no, I would have been -4. So if I'm... Bro, there's like buying and selling stock on steroids. So how do we calculate the right half? Because it actually matters. Oh, maybe you'd have to calculate from the back. The right half you'd have to calculate from the, you'd have to go backwards. And figure out what you would do if you bought and sold going backwards. Yeah, you'd probably have to go from the back half here. So you'd have to go in reverse to capture that right half. So it'd be like 8. If I hold, I'll be at 0. If I sold here, I'd be at 4. Yeah, we'd have to go backwards. And then here we'd know that if we had 8, and then all we need to do is flip these ones to 0. Bro, we need like multiple prefix sums. You need to know what happens if you follow the strategy so you can remove that part. Or follow the strategy here. Follow the strategy going from the right. Follow the strategy going from the left. Add those up. And then figure out how to clear this. By just removing. You go right half. Shit, I don't know how to solve this, man. This one cooked me. Let's see what Alpha sent. This is one that I feel like, yo, am I getting close? I feel like if I spend just a little bit more time, but I'm running out of time. Because if I know the right half, I know the left half. Okay, I'll know the left half, and I don't need to clear this part. I just need to know what happens if I sold every day from this point. And I could easily capture that with a prefix sum. So we just need to calculate a bunch of different things. Okay, I'm actually gonna solve this. Screw it. We're gonna capture from the right, and then we follow strategy from left. Yeah, I think we need to be able to know from the left and from the right. So we could just look to our right to know what's happening current strategy. So if we just follow the current strategy from the left, and then we sell every day, and then we just need to capture from right. This is gonna be disgusting code. For -1. So we're going backwards. We're going from bro, I haven't done a LeetCode in a minute for myself. This is from the left to the right. Shit, I need to look up the range function. Yeah, you do. Okay. You start at the left, and then you go to the back. So this one's like, okay, you go length of. Bro, I'm getting cooked. Strategy, and we go to -1 because this is inclusive. So we start in the end. So we go -1, and we work backwards. Bro, yeah, it's been a while since I actually had to. It's been a while since I actually did LeetCode for myself, other than interviewing kids. So strategy at index. So we can remove, yeah. We don't have to care about. For I and rank this strat. Yeah, but in hindsight, I'm like, how come I can't figure that out? But yeah. Honestly, reading the question at first, I didn't notice this part where it doesn't matter the constraint. So from right, we're gonna do at index equals print. Follow strategy is not defined. Where's follow? Oh. Okay. Oh yeah, okay, I think this strategy works. So for I in range, so you say left half equals zero if prices, if I minus K is less than 0, else from left I minus K. So when we go from here, I is here. Okay. Right half equals the right half. What's from right half here? Equals 0 if I plus K is greater equal to the length of prices, else from right I plus K. Now we just need to current. Now we just need to figure out the current window. Current window equals, like if I'm at here, what's my current window? Well, it's just like my current sell every day. Sell every day at I minus 0. It pretty much sell every day minus K divided by 2. So, but if K divided by 2 goes over, so it's 2 minus. So if I sell every day, that's 6. So I would have only got 2. But if so we just establish ourselves at K. There's gonna get index out. Oh, what the hell? Max of res left half plus right half plus. Okay, let's dry run this code now. Holy. Left, right, left, current window, right. Oh my god, so many prints. Okay, if I'm at 4, right? What's my left half? 0. What's my current window? Is I. Then to my right. Should we start right away at K? We could start right away at K. And then the result could be, if we just follow the strategy. Result could actually be just if we follow the strategy. Then we start at K minus 1. So if K equals 2, we start here. Okay, that so, okay, right half. Oh no, this is just plus 1. Just plus 1. Please work. Let's go. Bro, that was the hardest question I've done in months. I was doing some easy ones. I was doing like basic ones. Oh, damn. That was crazy. Dude, this code is ridiculous. Yo, y'all understand the solution? I think it's optimal when it comes to time, but I don't know if like 1 pass, 2 passes. Let's look at alpha codes. Alpha, you sent it? Bro, how is this medium? Yo, Grant, thank you, man. Yo, they said question 2 is easier than question 1. Okay, but I got somebody coming up next. Holy crap. Okay, I'm gonna try to do 1 contest question per day. Or not per day, per week, just to actually get better. Grant, appreciate you, man. Thanks for tuning in. Supporting the channel. Yo, chat, today we got, like, next up we have the Amazon guy again. The guy that we're prepping for Amazon. So, I mean, we've been putting him on, we've been testing him like crazy. So we're gonna get him right. I'm gonna grab a coffee. Just right outside my house real quick. Gonna grab a coffee. Give me a sec. I'll put on a DSA question. So you can relax to it. What?
Hello, can you hear me?
Yeah. Can you hear me okay?
Yep. Great, perfect. How are you doing today?
I'm good. How are you doing?
I'm doing good also. So I'm a software engineer at Cash App.
Cool.
And so I do like the company I work at does interviews a certain type of way. I don't know if like you have interviews coming up at a certain company. Like I can also like tailor maybe more to like what the type of question you might get asked at that type of company. But so tell me about like where you are, and that's the types of companies you're interviewing at, and then we can go from there.
Yeah, sounds great. Yeah, I do have some interviews coming up. So my background, I've been a software engineer for about 10 years, mostly at startups. I haven't really worked at FAANG before. I've been sort of transitioning into like more AI researchy stuff in the past couple of years. So I'm interviewing right now for a bunch of research engineer roles at Anthropic, DeepMind, OpenAI, all of those. So the two interviews I have coming up that I'm like most concerned about, I have one Google DeepMind coding interview coming up, and that's like the standard Google DSA thing that they use for the first live coding round. But that's not for a couple of weeks, so I'm not like too concerned about that. I have my Anthropic coding interview on Tuesday, so that's the one I'm like really focusing on right now. And that is like a little bit less LeetCodey and a little bit more practical. I don't know if you have anything along those lines. If not, it's fine. I'm happy to practice DSA as well.
Yeah, so my understanding of, I don't think I know much about how Anthropic interviews, but imagine it might be a little similar to OpenAI in the sense that like they kind of give you a question. It has multiple parts. You know, it's practical in the sense they want you to like, have some sort of input and correct output, but not so much like, this is dynamic programming, like find this optimization.
Yeah,
and so
exactly. It's like, it sounds very similar.
If that's the type of thing you're looking for, it's great, because that's kind of also the interviews that I conduct at work too.
Okay,
so I
perfect.
can just give you the question that I normally give for interviews.
Yeah, sounds great. Yeah, I know like a big part of it is just being able to like move really fast, because there's like parts that build on each other, and it's hard to like finish it in an hour.
Cool.
Yeah. All right. Sounds
great. We can get started then.
All right.
So this problem has a bunch of parts. It's kind of like, most candidates do like the passing grade is like the first 3 parts, and then the additional parts out of that are meant to just like fill in the hour and for like bonus points essentially. So if you're thinking about pacing yourself, like the first 3 parts is kind of like what you want to make sure you get done, and anything after that is extra.
Okay, nice.
So I'll paste the question here. And so what we'll say about these interviews where it's kind of like they want to make sure you get something done is that like you want to make sure that you don't want to be like rushing in the sense that you get straight into coding without thinking about the problem statement, but you also, you want to be cognizant of time at the same time. So like read the problem carefully, ask questions, like make sure like you understand really what's going on before you dive into coding, just to not waste time. And this first part of the question is pretty trivial, but it ratchets up the intensity. But you just want to like do the thinking up front instead of like necessarily like diving straight into coding and then going down rabbit holes and then not coding up the right thing.
Yeah, that makes sense. All right, cool. Yeah, let me just take a minute to read this. So you just want to count each character and the number of times that it occurs. Okay, well, I mean, can I solve this in a like really trivial way where I just use a counter? Or is that...
Yeah, you can use whatever standard library constructs you want.
I guess I should wrap this in a function, right? Because we'll be calling a function with inputs.
Yeah, and the latter parts of the problem, you'll be like reusing this part as too, so it'll be useful as something that you can call.
Okay, yeah, sounds good. Sorry, I can't type. Actually, yeah. Yeah, I think this is like all that you need to do for this problem. Am I like missing something really like stupid here, or like?
No, this first part is really trivial. Don't worry, the latter parts get a little harder.
All right, cool. So I should test it.
Run some.
Yeah.
Yeah. So start with like the example input and then like some boundary edge cases, and then we can get to the next problem.
Yeah, sounds good. Okay. And then let's just give it an empty string, and then any other obvious edge cases here. Let's make sure it still works when things are not all neatly like put together. Okay. Cool. Yeah, so I think that's the expected output. Yeah, you use an empty counter for an empty string. That makes sense. Unless you want like input validation to like raise an error or something.
No, I think that's fine.
Okay.
With this first part, since we're kind of just wrapping that standard library counter.
Yeah.
Okay, so this next part will probably take a little more analysis. So like, make sure to read it carefully, and then ask about anything that's not clear.
Sure.
And yeah, then can talk about like how you're thinking about solving the problem, and I'll let you know how that sounds, and I can get into coding.
Nice. Yeah. Okay. Yeah. This is more involved for sure. A data structure that will help give us that shorter encoding we talked about. What shorter encoding did we talk about? Okay. Well, anyway, we're looking for some kind of short encoding. Okay, so we're going to put it into a binary tree. Fine. Okay, so every character is a node. And then, okay, we build a tree, the lowest count at the root. And we take the node with the next lowest count. And it is a sibling. And we create a parent node. Okay. Interesting. Okay. Yeah, so we start with the lowest character value, make it a node, put the next lowest as a sibling, and they have a shared parent with an arbitrary or null character and the sum of their counts. Okay. And then we take the next lowest and add it as a sibling, okay, of this tree, and then just give it an arbitrary parent. Okay. So we'll end up with a tree where, yeah, basically, yeah, the value at each node is the sum of the values in the leaves of the tree. Is that right? So 1, 2, 6, 5. Yeah. So each node has the sum of the leaf values. Okay, that makes sense. Yeah, so this is not a binary search tree. This is just a binary tree. Okay, that makes sense. What do we want to use this for? I'm just curious.
It's eventually going to be used to encode these characters. I don't know if you're familiar with the Huffman encoding.
No.
But basically, well, actually, the next part will explain it. So,
okay, cool. Yeah,
we don't have to get ahead of ourselves.
Cool. All right. Build. Just out of curiosity, how annoying is my keyboard when I'm typing? I'm not sure how much picked up by my mic.
Maybe a little bit. I'm not super bothered by that type of thing, though.
All right, cool. I'm very sorry. See, on Google Meet, it has really good noise filtering, so like interviewers don't notice it, but on here, I think it's maybe pretty gnarly.
Yeah, it doesn't bother me too much, so don't worry about that.
All right, cool. So let's see, what's the best way to do this? I mean, the kind of obvious thing that occurs to me is to make this recursive, where this function, it takes in a counter, it takes in a current tree, and then it'll take the lowest item out of the counter, and like, yeah, combine it with the tree, and then return a new tree and a new counter, where the counter has had the used character removed from it. I mean, you could also do it iteratively. Yeah, you could just kind of have a while loop, like while there is still a character in the counter, and just on each iteration of the while loop, you could, yeah, remove the lowest count and build the tree iteratively, and maintain a pointer to the current root of the tree. That might be a little, yeah, maybe that's the better way to do it. Recursion is like a bit disfavored in Python, I guess. Doesn't handle like
Yeah,
really
and
big inputs well.
Yeah, and also think like in an interview like this where you're trying to finish things quickly, where like like both approaches would work, but recursion might be a little riskier to spend time to debug and a little less straightforward.
Yeah, that makes sense. Okay, cool. So I'm gonna, I guess I'm always gonna be building up the root of a tree. So I guess I'll start out with a empty root. I'll need to make a tree node class, I think. So yeah, this should be pretty simple. It just needs a count and a character. Yeah. And a left and a right, of course. I guess we can initialize the character to none, because often the character will be missing, but we always require a count to be provided. Unless you want to like automatically calculate the count from the left and right trees provided, but actually, I think that seems fine. Yeah, we can probably just have this class handle counting. Yeah, so everything can be none here.
All right. What question is this? Is it hard? Is it any hard, chat? Wait. No way, we had two in a row. Chat. Holy, how'd I get fried on that last question? Josh, what's up? Okay, bot.
And
What? This is the longest. What is this? This question's so long. Zero, how are you with LeetCode? Are you beginner? Is this stuff making sense? Okay. You're given an integer array nums of length n. Okay, I might have to do my blind 75 challenge now because the last guy wanted to see the other one. Holy crap. All right. Hey everyone, so today I'm going to take on LeetCode's most famous questions. This is the blind 75 LeetCode list. You see it has like 400, almost 450k views. Is that a million or? Oh, that's 4 million views. Yeah, so it literally has over 4 million views. This list is the most viewed list. This list is the list that everyone does to prepare. So I'm going to try to see how many of these questions I could solve in just 50 minutes, which is what it takes you, or how much time they give you in a regular coding interview. So yeah, pretty much that's what you're going to see. So I have a timer here, and let's just get started. Let me get through some of the fast ones. Two-sum. Classic hash map solution. So we just need to print out two indices such that the two indices hit the target. So we can do the hash map solution. We can do the map. And for num in nums, we need to keep track of the index. So enumerate here. If, so what are we looking for? We're looking for a number that if I add that number to my number, we get the target. So what we're looking for is if a number is that if we take the target and we minus the current number. So if we add it to our current number, we get the target. So if looking for in the hash map, return the current index, and then we'll do looking hash map of looking for, else we'll say hash map with the current num equal to index. That's question one. Question two, best time to buy and sell stock. So we just need to figure out the best time to buy and sell the stock so that we can maximize profit. So pretty much to solve this, you just want to buy at the lowest day and then sell at, you want to figure out what you want to pretty much sell at the lowest day and buy at, or buy at the lowest day and sell at the highest day. So if we just keep track of the minimum, it keeps try to sell at different prices, we could just take the result of that. Yeah, for price and prices, we're gonna return the result, and I'll get to the hard one soon. How much time? We've knocked off a couple minutes for price and price. And price equals load. Do 0 if, or we'll just do result here. For price and price, we'll do result equals, we're trying to maximize, so we'll take the max of the current price, or yeah, the current price minus the minimum price, and then the current result. And then what we're going to do is what's the length of, well, prices, maybe we could just do prices length, prices of 0. And then we're gonna just keeping track of the min price. So min price and the current price. I think we could just literally do that. And we're good. Contains duplicate. Okay, we're on question 3. We just need to keep track if any value appears at least twice, and return false if every element is distinct. So next guy's coming on in 40 minutes. So we'll do scene equals set for num in nums if num. Sounds good. Okay, basically we just need to see if there's any collisions in our hash map, and we return false, or we return true if any appears at least twice, and return false if every element is distinct. So we can just return false here, but if num is already in the scene, we return true, and then we do scene dot add the number. So if we do something like that, that works. Okay, question 3. Maximums product. This is long prefix someone. Okay, this one's a medium one. Given an integer array nums, return all the triplets. So how many have we solved? 3. Okay, I'll save this one for a second. Let's knock off the easy ones. What do we have here? Reverse a linked list, classic one. So we're given the head of a singly linked list, reverse the list, and return the reverse list. So pretty much we can just start at, so pretty much how are we gonna do this? Don't let me fold on reverse a linked list. We're gonna eventually have to do 2, 1. So 1 will, okay, so if we just keep a left and right, none, and the head, how many elements can we be given? Okay, if head is none, return none. Otherwise we do head equals to left. So what we're gonna do is we're gonna point the right pointer to none. So we'll say while right, and then we'll eventually return the left. What we're gonna do is while right, we'll do temp equals right dot next. Then we'll go right equals temp. But what we'll do is we'll do right dot next equals left equals right, and then right equals temp. I think that should work right there. How much should we solve? 4 so far? How much? Less than 10 minutes. Detect the cycle in linked list. Yo, chat, count for me. Okay, this is like a fast and slow pointer solution. Head. How many nodes? The number of nodes in the list is 0 to n. If head. So if head is none, return false. So this is a fast and slow pointer. We say while the fast exists and fast dot next will return false if there's a cycle. But if it reaches the end, there's no cycle. But essentially, if there's a cycle, it'll never end. So we just need to figure out when that's gonna happen. So we're gonna say if. So what we're gonna do is we're gonna say fast equals fast dot next. So it's gonna move dot next. Slow is just gonna slow dot next. If fast is equal to slow, if they ever equal the same thing, we would just return there. How many questions is that? 4 or 5? We'll check after. Merge 2 sorted list. Maximum depth of a binary tree. Okay, this one we have to do sort of a post order traversal. If root is none, return 0 left. So this one we have to do a post order traversal, and then we have to return. So what's the 1, 2, 3 return? So post order traversal, it'll return us the max on our left and the max on our right. So we'll do self dot max depth of left root dot left root dot right. And then we just say the max of left and right plus 1. Same tree. Let's invert and flip the binary tree first. So we're given the root of a binary tree, invert the tree, return its root. So I think we could just do this. Yeah, we could just do this recursive. We could do this sort of post order traversal. Wait, if I just flip. This is already, wait, how would I do this? So here, I would just flip them here. I think I just have to look at my child and flip them. But will they have to, I wonder if you have to do that in a post order or a pre-order manner. I think we could just, let's try with I think we could just do it a pre-order. So if root is none, we say temp equals root dot left equals root dot right equals temp, return root. Can we just do that? Oh no, it doesn't. So we might have to do a post order. Okay, we have to do a post order. Because we have to assume that it's already flipped, and then we just have to flip it. What's happening here? It's annoying how we can't visualize the tree. So, then we do post order, these flip. So 2 and 3, these flip. And then it eventually gets flipped. Okay, yeah, we need to do a post order. So we need to do right, left, equals self dot invert the tree, root dot left. And we'll do the same thing for our right. And then we say temp dot. And I think we could just literally do this. Okay, we have to do a post order to get that working. Okay, now the questions are getting slightly harder. Is it the same tree? Given the roots of 2 binary trees, write a function to check if they're the same or not. 2 binary trees are considered the same if they're structurally identical. So here we could just perform a DFS, like do a DFS simultaneously on the 2 nodes at the same time. 6, thank you. Maybe I'll do one. Sorry, I can do one after this. So while stack if p okay, basically what's happening is if they're not the same, if p let's see, yeah, you need to push novels also. So if p is not equal to, if p is none, let's just catch all the cases. Let's be hacky here. If p and not q, or q and not p, return false. If p is none, just continue. And we could be super explicit here. Continue. If p dot value is not equal to q dot value, return false. And then otherwise we just need to push them onto the stack. So what we're saying stack dot append p dot left, q dot left, stack dot append p dot right, q dot right, and we'll do p q equals stack dot pop. Seven. Is this deserialize a tree? Okay. Given the root of a binary tree, return the level order traversal. Okay, level order traversal is easy. So we start with levels here. Chat, how much have I solved now? Return levels. So we're gonna use a queue. From collections import DQ. So we'll use a DQ here. Say while the queue actually exists, or in range of length of the queue, what we're gonna do is if root is none, return empty. And we just need to push the value. Okay, for the level, it's empty. And then at the end, we'll do levels dot append the current level here. And we'll say for this in range, what we do if, we'll say element equals q dot pop left. Then we'll do level dot append lm dot value. Then we have to put its left and right children. If lm dot left exists, then we do q dot append lm dot left. Then we need to do the same with the right. Right here. What? For a while q. Oh shoot, I forgot to put the root. Okay. I'll get to those ones in a sec. Okay, what else? What's one should we do, chat? 8? Holy crap. How much time? 20 minutes? Okay, let's do number of islands, course schedule. So we'll do number of islands. I'm doing the ones that I can knock off fast. For yo chat, is it making sense? This different solutions like 0, you understand it? So what we're gonna need to do is loop through we're gonna return the number of islands here for row. For I in range, length of the grid. For j in the range, length of the grid 0. What we're gonna do is if the grid at I and j is equal to 1, what we're gonna do is we're gonna perform a DFS on there on the grid. So we'll just write out our own DFS, self grid row column, and then we'll say what we'll do is we'll do num islands plus equals 1. We'll set the current grid equal, or what we'll do is we'll call the DFS .dfs on the grid and the row and column. So we'll do is grid on the row and column is equal to 0 to zero it out. And then what we're gonna do is we're gonna loop through our neighbors, and that's gonna be pretty much the row and column here. So we're gonna go up 1, so -1, to the left 1, down 1, no, this is to the left and the other one was to the right. For row, column in the neighbors, if neighbor is less than 0 or neighbor is greater than equal to the length of the grid. Continue. Then we need to do the same thing. We need to do the same thing for the column. But if it's greater than equal to this, continue. If the grid row is actually equal to 0, we don't want to recurse, so we just continue, or we just return. Oh wait, yeah, we continue on sleep. Otherwise we want to perform DFS on that neighbor. We'll do grid. Holy, there's a lot of code. I think that'll work. Wait. What did it return? Output 9. If the grid equals 0. Is this easy? Can you do trapping rainwater? Hold up. I'll get there once I get there. So it's equals to 1. We increase this. We perform DFS. We go on I and J. Row column. Row minus 1. Column plus 1. We go row plus 1. Because I didn't call self. What's it returning now? Is it using the same grid? It's all 0. But why? If holy crap. So the first one, second one. Okay, this I should just use the stack. I should just use a stack. Should I just switch to a stack? Dude, it's getting hot in my apartment. It's the summer. So exit. Holy, this one's slowing me down. So we exit at 0 and 0. We exit at 0 and 1. Why didn't we loop through the neighbors? Slowing me down. Why didn't we loop through the neighbors? Should have. One. Oh my god, you're right. Got folded. Okay, output limit succeeded. Damn, that was a flop. Thanks, chat. Alex, you're a legend, man. Course schedule. Set matrix zeros. So, bro, this coffee, doing LeetCode, and it's hot outside is making me sweat like crazy. This is so funny. Okay, set zeros. Given if an element 0, its entire row. Given an n by n integer matrix, if an element is 0, set its entire row and column to zeros. You must do it in place. Okay. So there's only 1 0, but here there's 0 0. So I think we just need to keep track of calls to 0 out equals a set, rows to 0 out equals a set, and then what we just need to do is for I in range length of matrix, for j in range length of matrix, do we just need do not return it? Okay, what we need to do is if matrix, and then this right here is the columns. If the matrix at I in j is actually equal to 0, we're gonna say calls dot add j. Then we're gonna say the rows to 0. So we're just gonna keep track of which rows and columns we're gonna 0. Then we can 0 out the different rows. So we can write def 0 row self matrix row. So we say for I in range length of the matrix column. So this is actually j. We could do matrix row j equals 0. Make 0 out the column. We'll do column for, so we're saying I for each element in the matrix. I. We're gonna stay at a specific column and 0 that out. And then we'll just do for call in calls to 0. What we're gonna do is we're gonna 0 out the column, self dot 0 of the column, and we're gonna pass in the matrix, and then 0. How much have I solved so far? Holy crap. Only? How does that not match any outer? You gotta copy and paste to get these done fast. Valid anagram. Sort. This is not even this one's not optimal, but equals how do we sort this? Let's see. Can you just go like this? Group anagrams. Okay, we just need to figure out the count of each frequency and then throw it in there. Or actually, we just need to sort it. So we need groups for LM and string. We'll do is groups equal the groups of the sorted element we'll do from collections import default dict list groups sorted groups dot append element for key in groups result dot append groups at the key join union find would be crazy. Valid parentheses. Okay. How many did I solve so far? Oh, this is classic. Must be closed. Do we need to count this the number of ones of the same? Just the characters. Determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Okay. So I think we just need to keep the count of each type. So maybe we could do that in a hash map. Like this. We can just do something like this. We do this. What's the other one? This type. If lm in the type count, do type count lm plus equals 1. Else type count. Dude, I gotta capture all the cases. If lm equals this. Wait, how can we do this fast? Oh, we have to hit all these conditionals. We have to hit all these elif. Yeah, I'm just doing a bunch of the most popular interview questions. Wait, if it's this, then this. Oh, it's backwards. Otherwise, just backwards here. This is gonna be disgusting, but if the type count is less than 0. We'd have to do this. There's probably a way to clean this up, but we're going for speed. What? Oh, because it needs to close. This is not valid? Oh, we had to just use the regular stack approach. Use the regular stack approach. For element in S, if in openings, just do stack dot append the element. Else is closing. So we need to track closing. Then maybe we could do the reverse map here. So for opening, the closing is like this, and then how much time we have left? 11 minutes? Else, if it's a closing, if stack, if length of stack equals to 0, return false. Else, what we're gonna do, Charlie, you're funny, bro. Else, what we're gonna do is if the length of stack, otherwise what we're gonna do is elif stack, the last element is equal to, if it's not equal, if the last element is not equal to closing, oh no, this just needs to map from closing to opening. If the element is not here. Holy crap. That one took me a bit. 9 more minutes. A phrase is a valid palindrome after. How much did I do so far? 0. A phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all the non-alphanumericals, it reads the same forward and backwards. Okay. We just have to lower this. We have a left and right pointer. Left equals to 0, length of S. Minus 1. Wow. Left is less than right. If left is alpha, if it's false, then we just move left. Because we don't want to compare that. Right, it is alpha is false, then right minus equals 1. Because we don't want to compare that. Else, elif left. This should be S dot left. This should be S dot right. If S left is not equal to S right, if the left is not equal, we return false. Otherwise, else we left plus equals 1, right minus equals 1, return true. If is alpha is false, if is alpha is false, what is it breaking on? It might be the spaces. What? I lowered it. Oh, I forgot to store it here. Six minutes. Why would that? How is that false? Is it alpha? How do you check is? Is alnum. Never seen that function before. Holy, what can we possibly do real quick? Merge case sorted list. Insert merge intervals. None of these are fast no more. Climbing stairs. Yeah, I got another candidate coming up in like 2 minutes after this challenge. N equals 2. There are 2 ways to climb to the top. 1 plus 1. Yeah, so if... So what is n? N could be 1. So if you're at 1, n equals 1. Like there's only one way to get there. So we could do n minus 2 n minus 1. So if n is actually equal to 2, we return 2. If n is equal to 3, we start n minus 2 at 1, and here we have 2. So pretty much all we need to do is return. So how many times can we get to... Bro, I think I'm trying to solve this bottom up. Oh no, this one's, I won't solve this in time. What can I solve reasonably? Merge 2 sorted list. Okay, this one's possible real quick. So we're given while list 1 and list 2. Should be first return the head of the merge link list into one sorted list. So we have our sentinel equals node, just like a random node, and then we'll do next head equals sent. Then we'll do left or top equals. We're gonna try to do sort them in order, so we'll do float infinity if list one. If list one is none, else list one dot value. If top and bottom, if list one, bottom, if top is less than bottom, do something. If the top is less than bottom, what we're gonna do is head dot append I gotta clutch this one. Head dot append the top, else, or head dot next equals top, head dot next equals bottom. Otherwise we do head equals head dot next. Here if we move we'll move the top, so we'll do list one dot equals list one dot next. Here we'll do list two equals list two dot next. That'll work if it's even here, I think. But then there's just some cases gonna break. Equals head equals head dot, wait, top is less than bottom, then the head dot next, oh no, it's a value. Equals list one, list two. Okay, that solves it on one of the cases. There's an extra. I can't clutch this. Okay, chat, how much did I solve? It's ending. How much did I solve? Let's see. Then we got the next candidate up. One. Okay, I started like 45 minutes ago. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 14? Tragic. I thought I'd get more. Alright. Okay, we're getting the next candidate in. Give me a sec. Yo, what's up? Wait, let me grab some water. Give me a sec.
Yeah, no worries.
Yo, how you doing?
I'm doing good. How are you?
Good. You ready?
Yep. Ready.
Okay. grabbing something. Give me 2 seconds.
All right, take your time.
I'm gonna send you the coder link pad.
Okay, in the chat or in the what is that? GVC.
After this, gonna get back to vibe coding.
Yeah, what are you coding up?
It's like my website.
Okay, nice.
It's like I pulled like all my data down into a database, so I don't have to hit the API anymore. I want to have that in my own database, like all my videos and like hours, duration.
Like the
stuff.
metrics and stuff.
Oh yeah, I'm trying to put all the metrics in my own database because YouTube one has way too like they don't let you hit the database, or they have rate limits. So if it scales, I'm gonna hit the rate limit so quick.
Oh, I see.
So I just kind of scrape it, put it in my database, and then just let it.
Yeah, that makes sense.
Okay, let me think of what I'm gonna ask you today.
Okay.
Okay. Hey everyone, so today I have my friend from university, and we're gonna be putting him through a coding challenge, coding interview. Yeah. So, how good are you at LeetCoding, do you think? How hard should I go?
I've done a couple, but I haven't done them in like the past couple months, so we'll
Yeah.
see how it
No,
goes
just kidding.
today.
All right. Okay, is there anything off limits? No DP?
Anything's fine.
Anything's fine?
Yeah.
Okay, let me think of a good question. Have you done the Peralta 75 list?
No.
Okay, good. Ask you questions out of there.
All right, sounds good.
Go wait. Let me think of a good one.
All right.
Let me find one. Okay. Let me bring out one of my custom ones.
All right, sounds good. Custom one, nice.
So, what coding language are you gonna use? What programming language?
Let's do Python.
All right.
Use Python 3.
Python 3. Okay. So what we're gonna do is you're gonna be given a list of files.
Okay.
And your goal is to print out the files, print out the directory structure like this. So you're gonna print out web, app, assets, HTML. So there's two variations. I don't care which one you give me, just any variation. Here, you could either give me this variation or this variation, but yeah, you're gonna be given a list of files and just print it out.
Okay, got it. Let me think. And like the ordering doesn't matter? Like, is that the difference between the two variations? I'm just trying to figure this out.
Yeah, the order doesn't matter.
Got it. Okay. So, and I guess let me write it this way. So I guess can we assume that the formatting is always correct?
Yeah.
And then I guess it'll be like the last one will be the file. So will be the file. And then and then you mentioned ordering doesn't matter, right?
Yeah, ordering doesn't matter.
Ordering doesn't matter.
It's a well formatted string.
And then is this like 2 indents with some dash? Let me think what else there is. And then I guess if it's like a single file, then it'll just be, let me see. Okay, it'll just be in the root. Okay. So I think what makes sense for the solution is building up a try by processing each of the a prefix try based on each of the files by parsing it. And instead of letters, like I guess each node in the try would be before that, I guess by assuming correct format, one other thing to clarify is like is it possible for like it to be like a folder, like as like a file like in the input, or no? Like something
No,
like...
we just have to print out the files.
Right. So would this be possible where it's like hello or web app / assets as like would we get an input like this at all?
No.
Okay.
Like, would it matter? Your solution?
That's a good point. It would. If we're just using a try, it wouldn't. But I guess if we're using it somehow downstream, then it could. Like for example, like if this was actually a folder and this was the file's input, and then like let's say in the next input we suddenly get like these ones, we might not correctly understand, or like I guess the typing would need to be correctly interpreted, like if this happened like afterwards. And then
I mean, we're only calling it once, or we just need to parse it. Yeah.
Okay, then I think we could just use a try, do one pass to build the try, and then do a second pass to basically build the what is this? The structured output recursively. Do you think that solution makes sense to you?
Yeah, it makes sense. Just go ahead and implement.
Sure. Let's do files. I'll just copy this, and then we'll go print files, and then we'll go files list of strings. And I'm trying to think of whether I want to build the I guess we could just use nested dictionaries for the try. So we'll go, or let's call this root. And then we'll go for file and files. And then we'll go parts is equal to file dot split. We're splitting on this, and then we'll go build try parts, which is a list of strings. And then since we'll have access to root, if not parts, return. So if not parts, return Let me think. So if not parts return. Yeah, that's fine. And then we'll go for the first. So this will be like this, build try parts. So the first input we're going to get into this function is going to be web apps, or it's going to be like a MD string, web apps, assets, HTML, a.html. So we'll go parts 1, because we don't need the empty string part. And we'll go, and then we'll go current node. And this will be like a dictionary stir any. Oh, nice. That's pretty good. And we'll go if parts 0 not in current node parts 0. We'll set this up. And then we'll go build try parts 1. Let me see, do we need anything else? No, and then we just do this. So this will build the try, and then we'll go root, and then we'll go, oh, why is that? Oh, whoops, I need that there. We'll go print, what is this? We'll go print try. Let's see, build try, and then we'll print try, and then we'll go current node, depth. And then for the depth, we'll keep track of how many times we recursively called this. So we'll go current node. Remove this pass as well. Let's see. So we'll times spaces. White space is equal to times, what is this? 2 times depth. 2 spaces, and then we'll add the rest of the formatting. So
why are you timesing by 2? Is that how much a tab is?
Yeah, in your example, yeah.
Good. Yeah, it doesn't even really matter, honestly. But you could also just do like a tab right here, like this, if you want.
Yeah, that's true too. Yeah, I guess that's fine too. And then we'll go, let me think. Okay, so for, okay. So let's see, if not current node, so if the dictionary is empty, we return because we don't want to print anything. Otherwise, we'll go for kv in current node dot items. We'll go print. The key is, okay, so we'll go print. Let's see. Let's do this. string of white space. Is it dash dash space? Key. And then we just need to recurse on print try on the value. And then we'll go dep +1. And this should print it correctly. And then we'll just need to call it on the root. And then we'll do 0. Yep, 0 is correct. I think you ran it before. Oh, and then I need to add the call to print files. Files.
Let's see. Web app, assets, HTML. Index. What is your hello there? Oh, you added extra one? Okay.
Oh, yeah, wait. No, that was from the original input in the files. I think the example up was just not correct.
Mm-hmm. Okay. All right. We'll move on to the next question.
Okay. Oh, and then, yeah, if you need time and space complexity, I could run through that as well.
Oh, yeah. What's the time and space complexity?
Yeah, so let me see. Time complexity for each. It'll be what is that? Length of files, so the number of files, let's say files is n. Number of files is n. And then the max length of longest path is m. So in terms of files, it's going to be n, but in terms of the total, it's going to be n by n because the split is going to be linear time in terms of the max length of the longest path.
For what? What are you
The
talking
split?
about? Storage or
this is
time or
time. This is time.
Okay.
And then space is just going to be, yes, it's just going to be, what is this? Space is going to be n, just because you're only storing, what is that? You're not going to be storing like the duplicate m. It's just time that's increased by m.
Mm-hmm. Okay, makes sense. Let's move on to the next question.
Okay,
Let's step it up. That's good.
sounds good. Okay.
So yeah, for this one, we're going to be given a graph of nodes labeled from 0 to n minus 1. And then we're going to be given a integer n and a list of edges. We're basically going to be given a bunch of edges, and you just need to tell me if these edges make a valid tree.
Okay. Got it. Let me see.
Okay, I'll show you here, and you can work through the drawing if you want.
Okay. Okay, so 0 to n minus 1, like 0 index, the node IDs. Let's see. I guess I'll do the same thing here. Is a forest a tree? Like, should we consider a forest a tree? Or
What do you think?
do all the nodes need to be connected?
What do you think?
I think it would, well, in a real situation, I guess it would depend on the use case, because maybe we just don't want cycles, and that's what we define as a tree. But in this case, this example, let's see.
Like, we just need to see if it's a valid tree. Like, what makes a valid tree?
I'm not sure what the exact definition of a tree is.
Okay,
Like,
yeah, it's
well,
gonna be
I know
one.
the
It's gonna be
definition
one
of, like-
exact tree. Yeah. Okay.
Okay,
it
one
has to be
exact tree,
connected.
okay.
Yeah, one exact.
Got
tree.
it. Okay. Yeah. Okay. then we just it's just a graph without any cycles.
Mm-hmm.
Graph without cycles, not a forest. Let's see. And then in that case, and let's say we have like n is equal to 100. I guess if there's no edges, yeah, then it would be a forest. Yeah, so we need to make sure that we have all of these correctly, like they're all visited, like 0 to n minus 1. Make sure 0 to n minus 1 are all visited, otherwise it'd be singleton nodes forest. So it would be a forest. Let's see what else. I think that makes sense with me. What I'm thinking is, what I would do is create a graph based on the edges. So do one pass on the edges to create an adjacency list, or use a dictionary to basically represent one, and then do DFS traversal and make sure that we don't have any cycles, and also make sure that we visit all 0 to n minus 1 nodes. Does that solution make sense with you?
Mm-hmm. How are you going to track if there's no cycles?
So we could track that there's no cycles by, while we're traversing it, if we get to a node that's already in the visited set, that means that there's a cycle, because like we visited and we're on that path, and then we reach a node. So that would mean that we have visited, and then we just know that there's a cycle there.
Mm-hmm. Okay. Go ahead and implement.
Okay. We'll go, what is this? Indicates this undirected edge. Okay. Is tree and is int edges list of list. Let's see, and then we'll return false. Let's see. I will do this. Let me think. Okay, we don't need to worry about that in this one. What I was just thinking is, like, do we need to keep track of a route? But in this case, we could just start traversing from any, and then it shouldn't matter. We'll go. Let's see. Yeah. So this will build up the graph. And then we'll go visited, see what is set, DFS, no, int. We'll go true. For I in range, and if I not in visited, turn false. DFS node. Let's see. If let's see. DFS 0. It's DFS 0 has cycle. Actually, we'll do this. Is tree is easier. Not is tree. If node in not in if node in visited, we will return its false because it won't be a tree. And then we'll go for in graph node. So for the neighbor in graph node, and then we'll add visited dot.
What do you?
I used let me see. So visited dot add. Let me see node. We'll go. I just need to add one edge case. Basically handle when it's just 0, and then that's still a tree. Single node case. So I'm just noting that down so I don't forget, but I'll implement then the code. So for neighbor in graph node, let's see. DFS neighbor is equal to this. If return false, so this will return false. Otherwise, return true is tree. So I'll just do this. Before that, we could just say if 0 not in or I guess, yeah, if 0 not in graph.
What do you mean if 0?
Because the nodes is labeled from 0 to n-1, right?
Mm-hmm.
So if 0 is not in the graph, so that means it's not in the loop.
They'll pass you n, so there's the number of nodes.
Yeah, that's true. Yeah, so we could just return if n equal to 1, return true. Yeah, that's true. So is tree. I think this should work. I didn't add a call, but let's do this quick. So we'll go and 0 to 5, edges is that. We'll go is tree, or actually we'll go print is tree, and edges from that.
Should be true.
That should be true. Let me see. Why is that? If node in visited return false. Oh, I see. Yeah. Okay. I know why. So it's basically because we made this graph bidirectional, it's going from the child back up to the parent. And then that's why it's returning false. Let me think. So it's going down to the child. We could just avoid this by, I think, passing in the parent. And then if it's a parent, not doing the DFS on it. But does that work? Let me think. Does that work? Yeah, I think we just do that. So yeah, parent int if parent continue, else we'll go node and then we'll go -1. So that should return true. And then we could do test this one. So this one should return false. So yeah, so second example returns false.
Let's see. Let me throw this into. There's another bug though that I could just see off the bat. Actually, no. You might be able to get away with it based on the constraints. Okay, you want to do one more?
Yeah, sure. We could do one more.
Okay, you're going through these. All right. Let me think. I'll give you a low ball.
Oops. Sure.
Let me think. Give me a sec.
Yeah, take your time.
Your chat. Send some good ones. Okay, I got it. Or Alpha, he's doing this extra check though. That's why it's able to work. Right here. He's basically checking for each element if it was visited. Wait, let me pull out the question. How you feeling? Feeling nice?
Yeah, it's going good so far. We'll see. See how the last question goes.
If you don't solve this next one in 5 minutes, you're failing.
All right, we'll see.
I posted it now. So we're gonna be adding 2 strings, but there's decimals.
Got it. Okay. Let me think. I guess we'll run through this quickly. Can we assume that it's like there's no multiple decimals?
Multiple decimals?
Like it's
it's a well
valid
formatted?
input?
Yeah.
Yeah.
Like, is that really possible for a number?
No. Assume well formatted, like the actual string. Let me think. And I'm guessing like they're strings because let's see. Yeah, I guess can we assume that? Okay, yeah, just because it's a coding interview, I'm assuming we're not going to be able to convert this to basically like a float or a double to do the addition, right?
Yep.
Don't convert. And then if we're
and
not converting,
also if the decimals are more than 10, it's going to be in scientific notation.
Okay.
No, I'm just kidding.
Okay.
No,
Wait, or you just show?
Yeah,
Okay,
no, I'm
okay,
just
you're just
trolling.
joking. Okay.
Just like this.
Got it. Okay, yeah. And since we don't convert, we don't need to worry about like overflow. So to worry about overflow if we don't convert it. But obviously we're allowed to convert like one element at a time, right?
Yeah.
Okay. Let's see. Okay, so what I'm thinking is what we do is we basically count like how many let's say like tens, hundreds, thousands, like how many decimal points there are for each of them. And then so let's see. So for this one there's let's see, 5. For this one there's 3. So what you need to do is pad this with 2 more zeros. So this one's like essentially becomes this plus this, and then you just need to add like each place at a time, like 0 plus 3, so on and so forth, until while carrying any value that is beyond 9, and then add it to the next one, so on and so forth, until you get to the very end. And then let's say this carry left over, you just add that to the prepend it to the front, and then you could return that string, and that should get you the correct answer. So it's basically, it would be adding, it's just adding 2 integers, except we just need to pad it with whatever number of zeros to the one with less decimal places. Does that sound like an okay solution to you?
You're gonna pad the ones. Why do you have to pad it with zeros?
Basically, so you can actually you don't need to pad it with zeros, because then you could just carry. Yeah, that's a good point. You could just carry the 3 3 because
I'm just wondering if like, oh, you could actually do it without padding zeros.
Because if you don't pad the zeros, you just, because like this will never carry anything, right? Like 3 3 right here, the 3 3 that I'm highlighting.
Yeah.
So you could just that would be the end of the string all the time, and then you start afterwards. So it'd be similar, except you just offset it instead of padding the zeros. So it's like this will always be the case, and then because most it could be is 9, this will never carry anything. So you could just you start with some like list of strings where it's like blah blah blah, and then it'll be like 9 3. These will be strings, obviously, and then you start 1 plus 3, and this will be like 4. Let's see, 1, and yeah, so do that.
Okay, I think we're fine to pad it.
Okay,
Just to make things simpler.
Yeah.
I'm just thinking, okay, how about like placing the decimals, like working between the decimals?
Yeah, so working between the decimals, what we could do is split on the decimals. Let me think. Split on the decimals, and then do the decimal, like the right hand side first, and then if there's a carry, add it to. It would just basically adding like 3 integers, so it's like 2 3 2 1 plus 0 plus whatever carry plus some carry. So just add it to the like the first ones when you compute that. Does that make sense?
Sure.
Okay, so we'll go decimal, we'll go S1, S2, let's see. Okay. So we'll go, and then we want the output to be a string, right?
Yeah.
Okay, sounds good. Okay. S1, P1, actually, yeah. S1 int S1 S1 split. S2 int, S2 decimal, S2 dot split. Let's see. Oh, is equal to this. So yeah, so for this case, I'll use like what is that? A list, but I'd actually use a double-ended queue since we're prepending and we don't want to like basically be copying the list every single time to append to the front. But just for the sake of this interview, I'll just use this, but use DQ. Let's see, S1 int S. So max desc length is equal to max length of this, length of this. Pad 1 is equal to S1 length minus this minus this. Pad 2 is equal to whatever this is, and we'll just add like a helper function def add, and then we'll return a tuple. Let me do this afterwards. A sec. Tab 1 S1 decimal is equal to S1 decimal plus 0 times this is S2 actually. S2 pad 2. So now they should have the same number of zeros. And then let's say if we add them, let's say, what do we need to output? Get output. Yeah, sure, we'll just do that. Tuple lister, and then also what else? Int for the carry, add P1, P2, so I1, I2. And then we'll go, why is this incorrect? Oh,
what's a tuple?
Yeah, because what I want to use as helper function is for both, so we can't basically add the carry here. So that's why I added the returns result. Let's see, result carry. Turn. We'll just do this for now. Okay. -1. Okay, so we could just basically add it. So we go res equal to this. We'll go I is equal to let me think. I'm going to structure this. While I is, let's say less than length of I1, and I is less than length of I2, as I plus equal to 1. Carry is equal to 0. Let's see, L1 is equal to int I1 minus 1 minus I, L2. So this is getting like going from the last element forward. So we'll go I2.
Last element forward?
Yeah.
Okay.
So this is like, yeah, minus 1 minus I, and then we'll go val is equal to L1 plus L2 res plus carry actually. Then we'll go res dot
Minus
append.
1 minus I. Oh, you're going backwards?
Yeah. Because this function is going to also handle the front, I guess the front part. So that's why I implemented it this way. Because if we had the equal number of digits, then we don't need to go backwards. But or actually, we still need to go backwards. We would still need to go backwards in that case, just to handle the carry. Res dot append val mod. Okay. Val mod 10 stir, and then we'll go val introduced by 10. Actually, see, carry is equal to this, I plus equal to 1, and then we'll return res return carry. Let me see. And then, so this will handle when we pad it, but then obviously for like the left part of things, we need to handle a case where it's like, we all still need to add like, is that 232. So it's like that's still remaining. Let's see. Here, actually, we could just do this. Let's see. We could swap. We could just basically say like I1 is always going to be longer than I2 by saying if when I2 is greater than I1, I2 is equal to I2, I1. Always. So it's always greater than or equal to length of I2. So then we could say while I is less than the shorter one there, and then we'll add the rest. If I is, let's see, length of I1. So if this, we still have like characters that we need to process, we'll just do this. Length of I1 element, so we only need I1, L plus carry, I plus equal to 1. Okay, so this should work. Actually, we don't even need the if, because while is just going to catch that. So this is remaining, process remaining. So now we could just say decimal. Okay, we'll do des res carry. Carry is equal to add. Let's see. This, add that, and then we'll have to add carry. We'll allow carry to be passed in as an integer here, so that we could handle equal to 0. So we'll go. So this is a decimal part, and we'll go add int res int carry is equal to add s1 int s2 int, and then we need to add carry is equal to decimal carry, and then we just need to add if int carry. So if int res is equal to stir int carry plus int res. Now we could go return res equal to dot join. Oh, this is, oh no, that is correct. Wait, let's see. Okay, no, that's fine. Dot join.
What is split on? Anything or just spaces?
Yeah, that's what I was. Yeah, you're right. You need to do this. Dot join. Let's see. What are we joining? Int res plus the decimal plus join des res. Return the result. So let's try this out to see what happens. Let's see.
Yeah, we're at 50 minutes, so just run the code on some.
Yeah, I'm running it. Yeah. Oh, interesting. Okay. Oh, it's because yeah, my bad. Yeah, we have to do this. Res is equal to, yeah, this is back to what I was mentioning of, I just use a double-ended queue here, but I just used this instead. Or like if we were to use insert, same thing. Yeah, there we go. Yeah, that looks correct for that. Like 1 point. Yeah, and also while I was thinking, I was going to ask is basically, should we trim trailing zeros? Like if like we could just like trim trailing zeros as an option.
No, it's fine. Give me a sec.
Mm-hmm.
Verify. So how do you handle if the decimal portion are different lengths?
That's the padding right here. Pad 1, pad 2.
Oh, the decimal?
Yeah.
Oh, you
Only
padded? What about the integer part?
That's right here where I say length I2. If it's longer than I1, we'll do that. And then the second for loop is processing the remaining.
I see.
So like this add is basically like adding it just implements
Yeah.
add
makes
to
sense.
strings, but just returns carry instead of adding it to the end.
Yeah. Okay. All right. Yeah, it looks like it works. How do you think you did?
For this question in particular,
Or yeah, the whole interview. How was the questions?
they're okay. I think they're pretty straightforward, and I think um, that's a good thing. Not just for like, I guess, how I did, but also like in terms of like a technical interview, because I think it's like all the questions there was like also opportunities for like straightforward brute force solutions too.
Okay, let's look. Follow my cursor. Let's look at the code.
Let's see.
I think there's room for improvement on the last question because you did it a bit complicated. So this code right here,
Mhm.
I -1 -I.
Yeah.
It's a bit of a weird way to go backwards on it. Why not just reverse the like? I think you could have simplified it a lot if you just reverse.
Yeah, just go
the two
I is equal to
decimals.
length of, yeah.
Or even just because we need to work from the least significant digit to the most significant digit.
Oh, if you just
You
reverse
could just
yeah,
reverse
that's
the
fine.
input string, and it would have made
Yeah.
it a bit more simple.
Mm-hmm.
But like you're able to figure out here, because like you're incrementing, but then you're doing -1 minus the 0.
Mm-hmm.
So it's like it's going backwards. It still makes sense, but like it's still like I don't know if it's a matter of preference.
Mm-hmm.
Let's see. Yeah, I like how you flipped it here because that simplifies it. Could you have done that here as well? Like just flip the one that you want to pad.
All right. Yeah, that's true. That's true. Yeah.
Let's see. There's one area where it might have slowed down.
Yeah, that's why I
Right here,
said
it's
I'd
gonna
use
slow
a
it down.
double-ended queue. Yeah, yeah. I would use a double-ended queue there. But I just didn't want to look up the API for that.
Yeah. Okay, makes sense. No, it's solid job. Yeah. Just the main thing would just be it was just a bit complicated moving from the back. We could have reversed it, but I think overall you figured it out. Like as long as the candidate figures it out, it's fine.
Mm-hmm.
Okay, the tree question. Like you could get a bug here. Line 121. If n is equal to 1, it's not necessarily true. Because what if there's edges like loops to itself?
Oh, that's true.
But it's fine. Let's see. Because yeah, there could be edges if n equals 1.
Yeah, if n equals 1 and not edges.
What if n equals 2? Or n equals 0?
If n equals 0, if there's nothing, like, if there's no thing, then it's like, then it'd be true, because I guess, well, yeah, that's a good question. Is nothing a tree? I guess it would just
Yeah,
depend
I
on.
think so.
I was just asking the interviewer how this should be handled.
Okay, let's look down at the last one to try. Parts split. Yeah, no, this one's no concern. Like the super knit part would just be like just leveraging like the tabs and like to mimic tabs you could just use like dash t's and yeah, yeah, it's you did really good on the interview. Moving forward to
feedback?
the on-site. Not really. Just with the last question, like it was a bit hard to follow, but it was able to work.
Yeah, if the phone screen's 3 LeetCodes, I might withdraw my candidacy.
They better be
Craziest
paying, like,
phone screen
500
of all
bands.
time.
That was crazy. No, good job, man. Good
Thank
luck.
you.
For
Thank you.
Okay.
All right, thanks for your time.
All right, catch
All
you,
right.
man. Peace.
All right, peace.
Yo, chat, how do you think he did? What's the link for that file structure question? It's just the question I just came up with. Yeah, it's small nits. I just had to give some. I had to throw some feedback. He's able to solve it. It was just a little bit hard to follow at some points, but maybe I'm just burnt out. It's like 4 hours in. But tomorrow we got more people interviewing. We got 5 interviews tomorrow. Holy crap. Hopefully no one flops, bro. I'm gonna have to send out emails today to tell them, like, if you flop, like, just like, don't accept it if you're gonna flop, because we had 2 people out of 4 flop. But yo, maybe, I don't even know. I gotta figure out how to stop that. Wait, why is this guy? Bro, this guy flopped twice. Yeah, that's literally what I'm thinking. Like a small fee of like $20 or something, just so they don't flop. Cause nah, I don't know. Even like $10. Maybe I'll put it at $10. No, I don't give technicals that meta yet. I just started. Holy. Okay, that was good. That was good stuff. Take a look at the dinner queue when you can, by the way. Let me know what you think. Okay, where'd you send it? Yo, Cyclops, send it in the 2026 recruiting channel. Because that's where everyone's going to be posting their coding challenges and stuff like that, the OAs that they get, and then we're just gonna solve them. See the 20? There's too many channels. I gotta reduce it. Okay, did this sliding window. Okay, how did you solve this alpha? Yo, the Discord link is in my channel description. Cyclops, I don't know where you sent it. I don't see it. What is this? Codility? Is this new? Dude, this is crazy, Patrick. There are n people sitting at a round table having dinner. They are numbered from 0 to n-1 clockwise order. Initially, each person has a dish on the table in front of them. Person number K does not like the taste of, but has a dish of BK. We want everyone to have a dish of taste that they do not dislike. Wait, let me grab something. I'll be right back. So, somebody read this question real quick. So there are n people sitting at a round table having dinner. They are numbered from 0 to n-1 in clockwise order. Initially, each person has a dish on a table in front of them. Person number K does not like the taste of AK, but has a dish of taste BK. We want every person... Okay. In order to achieve this, you can rotate the whole table clockwise by 1 position any number of times. Okay. I see. I mean, the brute force is just... The brute force would be an O of n squared algorithm. Let's the minimum table rotations required so that BK 3, 6, 4, 5. Are the numbers kind of random? 2. Given A 1, 2, 3, 4, your function is returned 2. After rotating the table twice, we obtain has 1 in front of me. Bro, this thing is way too much words. Okay, where's the example? Okay, this is given A and B. Like, even the explanation is bad. Or just long. So this person doesn't like the taste of this, but has a dish of taste this. Okay. So this is the dish that they have, but they don't like this. This guy likes... Oh. Man, this is too long for me to read. I think the brute force is literally just like rotating it and then verifying if it's correct. But then how can you do that faster? How can you verify quickly that everyone has a dish that they like? Because that would be O of n squared. Yeah, what's up? Okay, essentially you just need to make it so that when you shift it, they're not the same. But like this one, it's false at first because this one is the same. If we shift it once, we get this, which doesn't work because 8, yeah. But it's not minimal. Okay. Let me think about it. Like, how can we shift it so it's going to be different? Okay, if we shift it once, if we shift B once, yeah, 8 will be there. Maybe we can like pre-calculate how many shifts it'll take to get something different. So and then take the minimum of those. So if we take this, if we know this one, how many shifts will this one be different? This one will take 1. Or how many shifts will this one be different? 0. How many shifts for this one to be different? It's already 0. How many shifts for this one to be different? 1. How many shifts will this one to be different? Or I don't even know. These are all different. Now this is a good question. It's kind of tricky. Because the brute force is just O of n squared. But do we want to get it faster? Is it even possible to brute force? Brute force is literally O of n squared. You just keep checking. So you're gonna loop n times. Each time you check if it's valid. So essentially what you're gonna do is you're gonna start the first loop, you're gonna start here and you're gonna loop. Second one, you're gonna start here and you're gonna loop like exactly n times, but you're gonna do a mod so you get to the back. And then you'll do the same for here. That would be O of n squared. Do we want to do it any faster? Cyclops? Maybe if we start deleting some we don't care about. Like if we don't care about 7. O of n plus total matches. What if we delete the ones that we don't care about? Then we shift. Yeah, maybe we just have to delete them and then shift. Shift this and then delete until they don't equal. And then we just see how many deletions it took. We can use like a double-ended queue. But what if... Like if any of them are... Yeah, I think that might be able to work. So if we have 1 and 1 here, what we can do is just shift it over 4, 3, 2. Shift it so we have something like this, and then we just kind of keep deleting. Wait, 1. How many deletions will it take? 1. Well, every time you actually every time you shift 1, it will actually, no matter how you flip it, calculate the nearest value. To know, can you provide an interactive way to learn DSA with Python for software roles? What do you mean by interactive? I think you could just do this brute force, honestly. Yeah, you could do this brute. Look how small the elements are. It's only 0 to 1,000. I think you just brute force this. I don't think it could be faster. Now let's look at the solution, ChatGPT. Like the constraints are too small. What do you mean O of n plus total matches? What's the optimal solution then? What? Okay. It's saying the Holy, that's interesting. I actually don't know. I haven't really done those like AI ones. I'll be curious to know what you think. I would just spam the AI as much as possible. Look, there's no way to really get it, Aziz. There's no way to get it past O of n squared. This is like some next level fast Fourier transform. This doesn't even make sense. Yeah, I'll just brute force it. Yeah, I would just spam. Dude, do the Black Hours, do the LeetCode Explore cards. Okay, okay, I'll save, I'll ask this tomorrow. And see what people say. Yeah, that's a good question. Thanks, Cyclops. This is good. I need, if you see any more good questions, just post it in in the 2026 channel. What's it called? Recruiting 2026 recruiting. Because I want to ask relevant questions. I don't want to just ask random questions off LeetCode. But yo, chat, I'm gonna get back to vibe coding. I'm gonna see y'all in the next stream. Tomorrow from 5 to 10, I'll be streaming. Catch y'all in the next stream. Thanks for tuning in. Really appreciate it. Those were some really good interviews. But we're gonna continue to help people out. We're gonna continue to help people get jobs. We're gonna continue to ask LeetCode questions, like keep working on through LeetCode questions. Pretty much through the end of the year, and then probably in February, March, probably we'll switch up the content, because we already have helped everyone get a job. So we'll see how it goes. But thanks for tuning in. I'll see y'all in the next stream. Wait, Sai, you want me to review your resume real quick? I almost dipped. I forgot. I got you right now. Wait, hold up. We'll do one resume review. Dude, your font is too small, bro. Your font is literally tiny. That's one thing. It's really hard to see the bullet points, because you're forcing way too much stuff in there. Education experience, projects, technical skills. University of Minnesota. You have a really good GPA. That's good. Keep it up. Software engineering research. Contributed a responsive web app using React, JavaScript, and Vite to help users reflect on purchase history and promote mindful spending through an intuitive, accessible interface. Parsed and visualized 100 plus Amazon orders by integrating order history reports with the product advertising API, displaying product images and metadata to improve user reflection accuracy by 65%. Implemented accessibility features and unit tests to ensure broad usability and reliability, and optimized component load times to improve scalability for high order data. Implemented accessibility features and unit tests to ensure broad usability and reliability, and optimized component load times to improve scalability for high order data sets. How many people ended up using this app? I would add in some metrics like that. I would add in some metrics. I think these bullet points, you could add more technical depth, like try to make it sound like add more. Let me reread again. Contribute to responsive web app using React. So you built a web app. That's good. One way to improve this is just talk about how many users actually used it. Parse and visualize 100 plus Amazon resumes by integrating order history reports with the product. User reflection. Okay. Delivered exceptional customer service by actively identifying the needs. Okay. Yo, it's cutting off here. It's a bit weird. It's because you're making the you're making the font too small. That's why it's doing that. Collaborate with a diverse. Okay, maybe you could remove the Nike because it's even shorter than Outlier because you're already running out of space. So you could remove Nike because it's not as relevant. It's still good to have experience, but since you already have other software engineering experience, you don't really need to put like non-software engineering experience in there. Like pretty much after I got my first internship, I just stopped adding any retail experience that I had because I also worked retail as well. So you could remove that. Yeah, remove this Nike one because you already have 4 other bullet points and you're already using up way too much space. Try to tell me how many people actually use this. Try put in metrics for here. So you trained an AI chatbot to debug and generate code. Like what was the metrics for problem solving? Was there precision? Was there recall? Was there some sort of metric that you tracked to know that the bot that you're training was getting better at that, or is better than some specific baseline? So when you say enhancing their performance and accuracy, how much did you enhance their performance and accuracy? You need to quantify those. Collaborate with a diverse group of 30+ CS students to explore career paths, participate in peer-led workshops, and strengthen technical skills through discussions in real world. Practice coding through weekly sessions and project-based activities. Yeah, that's pretty much my advice for now. Let's look at the projects. Okay, the projects are also good, but you can take the steps. You can take all of these projects further by actually trying to deploy it and put it in front of people and actually getting users, because that will give you a really good resume when you actually have some apps that people use and you have to manage it in production, because it gives you real world experience that way. I think these are still good, but it doesn't look like people are using them. So that's where I would take that a step further. But yeah, that's pretty much. Yeah, I like the format. Just the font is really, really, really tiny. So I would remove the Nike experience. And like, if it's still small, you can't raise the font. Have the font at least 12 or 14, I think. You could remove one of these. But thanks again. I'll catch y'all in the next stream.
This is not my main thing, really I'm a coder. Coffee stains and name chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. LeetCode, beast mode, 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 LeetCode, beast mode. This is not my main thing, really I'm a coder. Coffee stains and name chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. LeetCode, beast mode.